everyone, welcome back to my YouTube channel. Again, my name is Rica Casabuena from ECE 41 of the Electronics Engineering Department of the De La Salle University Das Marinas. And for today's experiment, we will be having our Internet of Things lecture, which will involve simple applications of Raspberry Pi for our IoT lecture experiment, which is creating applications using input and output or GPIO ports of our Raspberry Pi. So this is submitted to Engineer Longares, our IoT lecturer professor. So for our objectives, we aim to create a Python code for a simple application experiment to blink an LED using Raspberry Pi input-output GPIO ports. So for this experiment, we'll be requiring the experimenters to use an LED and a Raspberry Pi 4 as their microcontroller. So for our procedure, we'll be installing our GPIO 0. So this is important. Okay, GPIO 0 is installed by default in the Raspbian image, and the Raspberry Pi desktop image for PC and Mac both available from raspberrypi.org. So first, we should update our repositories list. So you can actually check this instructions in NetAcad if you want to study it by yourself. Then we can install the package for Python 3, okay, uh, using these codes. And then for importing GPIO 0, in Python, libraries and functions used in a script must be imported by name at the top of the file with exemption of the functions built into Python by default. So let's say, for example, to use button interface from GPIO 0, it should be explicitly imported. Okay, so all of the interfaces should be imported if you're going to use those interfaces for it to function well, okay, to avoid any errors. So in this case, all references to items within GPIO 0 must be prefixed. So for the pin numbering, the library uses Broadcom BCM pin numbering for the GPIO pins as opposed to physical board numbering. Unlike in the RPI.GPIO library, this is not configurable. So any pin marked GPIO in the diagram below, which will I be showing you later, can be used as a pin number. So for example, if an LED was attached to GPIO 17, you would specify the pin number as 17 rather than 11. So with that, let's explain this one. So this is our Raspberry Pi 4. So uh, you can actually familiarize with the GPIO pins, but all of the resources can be check on the net, so you can actually have this copy by yourself. So just like what we've said a while ago, you can set the GPIO pins whether you like it as an input or you like it as our output. But you have to take note the specific number of the Raspberry pin that is specifically for the input voltage and for the ground. So let's say for this one, we have our pin number 1 here of the Raspberry. So it is intended for 3.3 volts. Then pin number 2 will be for 5 volts as well as for pin number 4. So we'll be connecting it to our 5 volts. Then for our ground, we'll be setting aside specifically pin number 39 of our GPIO pin of our Raspberry 4, which is pin number 39, as the connection to our ground. Then the rest, actually pin 17 can be our input voltage for 3.3 volts as well. Then the rest, it will be up to you whether you'll be considering it as your input or as your output. So here, you can see here, our Raspberry 4 has 40 pins in total. Okay? So 2 for the 5 volts, 1 for the, actually, you can also consider pin 34 for the ground and then pin 25 for the ground, then pin 20 as well, then pin 14. It's up to you. Pin number 9 is also for ground. So it's up to you where you would connect your LEDs as your input and as your output. Okay? So this will be our setup. So we'll be connecting LED to pin number to GP17 of our Raspberry. Okay, we'll be connecting the LED to a resistor, and this resistor will be connected in series with the LED, and it will be connected to the GP17 of our Raspberry 4. Then you have to take note that the one foot of our LED should be connected to the ground, so we can have a proper connection of grounding. So you have to take note of the Python code to make the circuit work, and after that, you can construct the actual circuit assembly using the Raspberry and using the circuit components, and then you just have to import the Python code using our Raspberry, our microcontroller. Then you can run it, and you can use our 5 volts voltage supply to run the circuit. So all you have to do is just type this code. So from GPIO 0 import LED, from time import slip, and then red is equals to LED 17. It's 17 because it's connected to GP 17. Then while true, if the condition is true, the LED connected to the pin number 17 will be turned on. So we'll be having a delay of 1 second. And then after that, it will be turned off, and then we'll be having again a delay of 1 second. So alternatively, we can consider another code. So from GPIO 0 import LED, from signal import pause. So it's up to you what kind of code are you going to use. So red is equals to LED 17. Again, it's connected to pin number 17 of our Raspberry 4. And then red dot blink. So this explains the blinking function of the LED, and then we'll be considering pause and as an alternative to the code of sleep here on the first code. So with that, let's perform the actual circuit assembly. So for our circuit assembly, we will be showing how to repeatedly turn off and turn on our single LED, which is connected to our Raspberry Pi 4 and in series with a 360 ohm resistor. So as you can see, it's connected to the pin number 17 of our Raspberry 4. So let's have the application of the circuit. So as you can see here, we use a green LED, and we repeatedly turn on and turn off this LED using our code that we uploaded on our Raspberry 4. So this is a simple application of our Raspberry Pi 4, which can be applied in Christmas light, okay, or in simple applications in our everyday life. So that's our simple application. So it is turning on and off repeatedly automatically, okay, because the Raspberry Pi 4 is programmed to perform that function. So as you can see, there is a delay of 1 second for every turning on and turning off of the LED, okay, with respect to the Python code that we used a while ago. So this is a simple application which we can observe in our everyday life, in our homes, and in the industries. So again, my name is Rica Casabuena, and see you on our next vlog.